Hello again. As you know, I am Eli, and we're going to continue this A plus track by talking about PC cooling today. So, whenever you talk about different types of technology, there are fundamental concepts to whatever that type of technology is. And when you're dealing with PCs and when you're dealing with servers, cooling is one of your biggest issues. You're going to be having these systems on. Many times they're going to be running 24/7. And if you haven't thought about the cooling situation and how you're going to be dealing with cooling with your systems, you can have a lot of problems. We are going to deal with this as its own individual class because this is one of those topics that spans almost everything that you're going to be dealing with the computer. Whether you put in a big ass case fan like this, depending on what graphics card you're going to purchase, what kind of heat sink you're going to put on your CPU. Heat is just one of those integral topics whenever you're talking about computers, and if you get it wrong, you can have a lot of issues. Back in the day when I had my consulting company, I made a lot of money essentially by cleaning out heat problems. Basically, CPU heatsink fans would fail. Computer cases would just get clogged with cat hair and other things. I even had a computer that literally died from secondhand smoke. Do you want to know when you need to quit smoking? When your computer dies from secondhand smoke. Literally. I sat there and I was doing all this troubleshooting with the computer. So I tried to do antivirus and anti-malware. I tried to do updates. Oh, it would keep freezing. It would keep locking up, and I didn't understand. Right? The fan spun how the fan was supposed to spin. I even had the side off the case. So there should be enough air getting into the CPU and everything to cool it off. And I was sitting there just scratching my head, trying to figure out what is the problem with this computer. And then I just sit there, right? I've gone through all the troubleshooting, right? What is it like? When you finish doing all the troubleshooting that seems reasonable, that's when you get into the troubleshooting that becomes absurd. And so I was sitting there, I'd done all the normal troubleshooting, and then I looked down at the CPU heatsink, and it was like this brown color. So CPU heat sinks, basically these are made out of aluminum, and so generally they're silver. Maybe if they're painted, they're black, but they more or less they should either be silver or black. And when I looked down at this one, it was brown, and I was like, well, that's weird. But to be clear, there wasn't dust and dirt on it. It just looked brownish. So that's bizarre. And so I had run out of every other thing I could do to this computer. So I was like, maybe the heatsink is just maybe whatever that brown stuff isn't what's supposed to be there. Maybe that's not paint or whatever. And so I pulled the whole CPU heatsink contraption apart, pulled out the aluminum block, went over to the sink, washed it off with Dawn, and just all this brown just tar just oozed off of the heatsink. Cleaned it up, made it look all nice and silver, dried it off, waited for it to dry, plugged everything back in, and wow, that computer spun up and it worked like a champ. All because of a heat issue. So, when we talk about heat can cause you lots and lots of different problems in your computer. So, always make sure that however the heat is supposed to be dissipating in your computer, that it's working properly. And think about weird stuff. When you get done troubleshooting all the normal problems, look for the absurd problems because sometimes the absurd problems are where the real issue is. So a big question should be, how big a deal is the cooling stuff really, right? You go to YouTube, you watch, Jay's Two Cents, you watch all these other tech YouTubers, and they're talking about liquid cooling, and they're talking about big old fans, and then at a certain point, you really have to ask yourself, is cooling really that important, or are these people just trying to figure out topics to talk about? And the reality is it's somewhere in the middle, depending on what the situation is for the system that you're dealing with, and what you plan to do with the systems. So to be clear, heat is a real problem. Like there is no doubt. Too much heat will kill your computer, right? So again, if your heat sink gets gunked up, if the fans fail, if whatever else, if you're not getting some cooling into your system, you're basically what happens is the CPU has a special sensor on it, and when the CPU detects that it's getting too hot and that it will get to a place where it will actually do physical damage to itself, it literally just shuts itself off. That's why you'll see with heat issues, you'll run into problems where computers will freeze up or they'll just turn off. You'll be doing something and they just turn off. And the reason for that is the CPU. Sometimes things like the GPUs now, they have heat sensors on them. When that heat gets too hot, it just shuts off, and then you sit there and try to figure out how to troubleshoot. So to be clear, with like real heat, like heat with computers being way too hot, yes, that can cause a major issue. But then the question is, obviously, no crap, Eli, that's a problem. But what about all these people putting liquid cooling into their computers and all of that kind of stuff? Basically, the question there with the cooling is, what do you plan to be doing with your system, and essentially, how hard are you going to be pushing your system? So if you have Right, if you have a little server, or not a little server, a little computer, and you're essentially going to be giving it to the secretary, and the secretary is going to be doing word processing and is going to be doing watching YouTube videos and doing Facebook and all that, right? Heat is probably not going to be a major issue for that person. The reason being is because everything is in the system is going to warm up to about where it normally sits at, and then it'll just keep trucking along. So again, you go into warehouses. I've been to a lot of warehouses. You go into warehouses, and the inside looks like a little Dyson vacuum cleaner. You open it up and there's all kinds of crap in there. And you think, well, how is that able to keep functioning without overheating? And just the reality is that the people using the computers don't push them very hard. They're low power components in there. So overall, they just don't get very hot. So, 4, 5, 10 degrees for these components, it doesn't really matter because they're just not doing a lot. Well, the thing is once you start getting into the world of servers or gaming systems, that's when you can really start to have heat issues. The reason being is because with these kind of systems, you may be pushing them to the absolute limit. Again, with a lot of the video gamers, why Jay's 2 cents talks a lot about cooling is because he's a gamer. He creates gaming PCs. And so with the gamers, to each their own, to each their own. They really like overclocking systems. Anything they can overclock, they overclock. If they could figure out how to overclock a keyboard, they would overclock a keyboard, right? So you put all these components into one of these gaming systems, and they're going to be running warm anyway, and then you decide to overclock. So basically what you're trying to do is you're trying to push all the components past where the manufacturer has told you that they'll reliably operate at. Well, when you start pushing them past that point, obviously they're going to get hotter and hotter and hotter. The hotter the components get, the more unstable they get, and so therefore you want to try to cool them down. And so that's why the gamers, they get all these liquid cooling systems going on. The reason being is because they're trying to keep the components as cool as possible because they're physically pushing those components as hard as they can. So in that kind of environment, cooling can be a really big deal. The same is true with things like servers. Again, with servers, you're going to be pushing the hard drives, you're going to be pushing the processors and all of that. And the cooler that you can keep those components, the less likely it is that they'll fail and that you'll run into issues. And so this is one of those things you have to be thinking about cooling. Cooling is a real, again, if it gets too hot, any computer is going to shut down. But this is one of those where if you're doing gaming, if you're going to do servers, that type of thing, cooling is a really incredibly big deal. Again, to be honest, if you're giving a computer to a warehouse worker, if you're giving a computer to a secretary, you give them some little i3 thing. Yeah. Don't get me wrong. You got to clean out the vents. You got to make sure the fans spin. But it's probably not going to be the biggest issue there. Now, as a professional, when you start thinking about cooling and start thinking about how you're going to keep all of your systems cool so that you don't have to do any more troubleshooting than necessary, the first thing that you need to think about is speccing out your systems from the get-go. One of the big problems that I see is that a lot of the troubleshooting that you have to do for people's computers many times is because they were given a computer that's far superior in resources to what they need. They just need a nice little simple simple box that will stay relatively cool on its own, and instead, they got a 1080, Ti video card or something in this thing. The reason being is because the geek or the tech said, well, they're having sales on those video cards this week, so I decided to buy one. And so the problem is, again, the hotter the components, basically the more high end the components, the warmer those components are going to run, the more likely you're going to run into heat issues. It's just a basic thing. And so if you have somebody and all they're doing is they're running productivity software, web browsers, YouTube, and all that, one of the things you should be thinking about is how low can you spec the computers? Can you spec them with very low quality processors or low speed processors, low speed graphics cards, so you're not going to have to run into heat issues? That's one thing, like with this particular graphics card. So this is an absolutely new graphics card. I actually bought it for the system that I'm ripping apart and showing you folks while I do this A Plus series. And one of the things you'll notice with this graphics card is that there is no fan on this graphics card. So all it has is the aluminum heatsink right on top of the GPU, and then the case cooling is what keeps this particular graphics card cool. The reason being is because more or less, this is a 5-year-old architecture. This is a relatively cool GPU, and therefore it doesn't need the fan to spin to keep it cool. Now, again, you sit there, you think about it. If you're going to do video gaming, no, you don't do this. If you're going to do VR, no, you don't use this. But if you're going to do web browsing, if you're going to do YouTube, this has a gig of video memory on it. It will be more than fine enough. And why I like these types of graphics cards without the CPU fan is I saw time and time again where the CPU fan on the graphics card is usually what fails, and that caused problems with the graphics cards. You don't know how many times, desktop computer, it wasn't working properly, I'd crack open the case, and you would literally just see the fan blade for the graphics card sitting at the bottom of the case. You're like, oh, yep, there's your problem right there, right? So if you get a graphics card or other thing that doesn't need a fan in order to keep it cool, then that's one less component that can cause you problems as far as heat's concerned. Again, in this modern world where we start talking about these small microcomputers, this is one of those things that you should be thinking about from a heat standpoint. Is if your people, all they're going to be doing is again the basic productivity stuff. Do you need a full-size desktop computer anyway? Again, this is something from Azul Tech. Azul Tech sends me all these kinds of little computers and products to take a look at, and it's surprisingly powerful. Again, this little guy here, I think it has a quad-core processor. I think this has 4 gigs of RAM, has 32 gigs of storage. That's upgradable. Has Windows 10 Professional in it, all in this little computer. And so that's one thing. Like this, you're not going to have to worry about heat issues the same way as if you have a full-fledged desktop computer. This entire little thing here most likely puts out less heat than simply a normal desktop power supply. Again, something to be thinking about with these small microcomputers, even as far as servers are concerned. I know that may seem like sacrilege, but I know one consultant that literally uses nukes. So Intel's Next Unit Computing, those really small little computers. He actually uses those for full-fledged servers. So he goes into small business environments, he installs Windows 2012 server onto one of those little nukes, and that is actually their Active Directory server. Now I know it sounds funny, but again, in an environment where you don't need a lot of server resources, this allows him to put it in, you don't have to worry about a server room and all that. You can put it in a little location. You don't have to worry about overheating the system or any of that kind of stuff. And so this is one of those things that you should be thinking about. Again, at the end of the day, heat issues are going to end up causing a lot of problems, especially if you're in an enterprise environment. And so if you can do little things such as migrate people down to smaller computers like this, or simply use graphics cards or such that don't need extra fans or such, that can cause you that can be a real benefit at the end of the day. Now, the next thing that you need to be thinking about when you're thinking about cooling your computer is what environment is it going to be put into. The harsher the environment you're going to put it into, the more that you're going to have to worry about cooling. So if you're here in the United States and you're in an office building and the office building is kept at a nice, I don't know, somewhere between 70 to 75 degrees during the summer, then you're probably not going to run into a whole lot of heat issues unless something fan specifically fails. The reason being is the ambient air around the computer is relatively cool. Basically, that relatively cool air gets sucked into the computer, it gets heated up, it gets spit out. The big old air conditioner for the building cools the air, and everything's pretty hunky-dory. But one of the things you have to be thinking about is, what about if you're not in a normal office environment? What if you're in an environment that doesn't have HVAC? So when it's 95 degrees outside, it's 98 degrees inside. This is something to be thinking about. Now, again, like I talk about that when I had clients that had warehouse environments, I had clients who had stables, and that was one issue that we actually ran into with one of their systems. Oh, you ever wonder why I don't go back into the field? Because I don't want to deal with customers again. We sold one of my customers. We sold a very fancy digital surveillance system back in the day. It was a 16 camera. Oh, it was GeoVision, I think it was GeoVision. High end, high end surveillance system. Here's the thing. They showed me the office. They showed me the office that we were going to be putting it into, and it was in a stable. So they had a fancy stable where people with fancy horses put their fancy horses, right? And so I go in there, and they're building everything out. And so when they're talking about the surveillance system, you have to run all the cables, because this was an IP cable. This was coax cable. All that has to go back to the one location. And so I sit there and look at them and say, okay, well, this is going to be a pretty powerful little server in order to be able to do this DVR stuff. And so I want to make sure this room the door is going to be closed, and it's going to have air conditioning, right? And they said, yes, of course it is. So, okay. So they spent a lot of money on the surveillance system, and yeah, they destroyed the server within the first year. That was a very interesting conversation about warranties. They're like, well, we have a warranty. It's like, no. It's one of those things when you try to claim warranty with some faceless company like Dell. Hey, it's like when you try to claim warranty and you're like, I told you the environment, and that was a problem. Is it was in the stables, and it was dirty, and it was disgusting, and for whatever reason, they never got around to installing the air conditioner into that room. And so you go into that room, again, 95 outside, it's 100 degrees in that room, plus it's dusty and dirty. And the problem is things got gunked up and stuff failed. And so this is one of those things you have to be thinking about, is the environment you're going to be putting systems in. I'm going to show you different types of heat sinks, and basically heat sinks that have fans and heat sinks without fans. And to be clear, right, if you're going to be putting your computer or your system or your appliance into an environment that's going to be dusty and dirty and hot, one of the things you may be thinking is, do you actually want fans on your CPU heatsink and on your graphics card, because they may get gunked up, they may fail, and then that may cause a system to fail. Going with a heatsink that doesn't require a fan may be useful. Again, the same thing is true with looking at cases. So a lot of cases now, they'll have like fine mesh over the vents, essentially in order to be like air filters. And again, if you have air filters on your system and it's sitting in an office environment, it's still going to add up to more troubleshooting calls. It's going to add to your workload at the end of the day, but probably not absolutely horrible. It won't be horrible. But again, you put a computer into something like a stables where there's just this fine dusty crap everywhere. If you have air filters on your computer, that computer's going to get shut down by the end of the day. Things to be thinking about with the environment. Beyond that, things to be thinking about is simply like the computer desks and where you're going to be putting the computer. One of the problems I used to see is computer desks, for some reason, it's not, most people now just have flat desks and they put the computer under it, but computer desks used to have like this side cabinet to them, and in that side cabinet is where you put your tower computer. So basically you slide your tower computer there and run the cables up. It's supposed to keep it all nice and clean. Well, the problem is people turn on their computer and then they shut the door to that little thing, and then it shuts off after half an hour, and they don't understand why, and they call out the geek to try to fix the problem, and the reason is because basically you turn it on, and the only air that that computer can get is whatever is in that little cabinet. As soon as it heats up that cabinet, then everything shuts down because there's a heat problem. I also saw this with companies where they had a server room. So basically, they used a broom closet for a server room. A lot of broom closets don't even have vents in the door. So they'd be surprised. They put a couple of servers into that broom closet, and then they don't know why they're crashing every day or so. The reason is because the broom closet would get too warm, then all the systems inside was shut down. So these are things you're going to have to be thinking about with cooling. Is again, it's not just suspecting the system. Think about what the system should be, what's actually required, and then look at the environment that it's going to go into, and try to match those two things to figure out how you're going to cool your computer and make sure the cooling mechanisms you have are appropriate for what's going on. Now, as I was talking about when I'm talking about the environment for the cooling situation for your computer, the other thing that you're going to be thinking about is the case itself and how well designed is the case that the computer is in for the cooling environment and the cooling situation that you're going to be using the system in. This can be a real problem. Especially like a lot of the less expensive cases. Again, you get down in those little $20 cases, is you'll have a couple of little holes, basically a couple of little grills about this big. You throw in a 1080 Ti, you throw in an i9 processor, and all of a sudden you have a nice little barbecue on your hands, right? So that's one of the things you have to be thinking about is with all the components is putting those components into the case and then figuring out, is there going to be enough airflow in the case in order to keep all the components cool. Now, one thing to think about is if you're running into heat issues and you have a computer, one way you can try to solve the heat issues nowadays is you can simply go out to Micro Center or Newegg and buy case fans. So if the system is getting too hot, it's got all the holes it's ever going to have. Something to think about is you can put in case fans, and those case fans will either be able to push air in and pull it out. Generally, you put one on one side. So you put an the exhaust vent on the back and an intake fan on the front. Basically, that pulls the air through. But that's one way you can try to keep the case so that it's cool. This is an issue too with a lot of the cases that look cool, like, ooh, wow, that's a fancy case. Well, the thing is, air intake or exhaust, grills don't always look the coolest, don't always look the sexiest. So one of the problems you run into is a lot of these case manufacturers, they'll try to hide the little grills in weird, bizarre places. And what you find a lot of times is how they hide those grills actually cuts down on the air circulation a lot. You may have this huge area for a grill, but then it has a faceplate over it and has a tiny little intake. So you look at it, you're like, well, this grill is huge, but the actual air intake for the grill is incredibly small. Or a problem that you can have, especially as these computers and cases get fancier, is I was watching a review by Jay's Two Cents talking about this one gamer case where in order to keep it all streamlined, when the computer is powered off, there are no grills. Like when you look at it, you can't see any air intake. And the reason is because when you turn it on, you press a button and then it kind of has like this little air intake tower that rises up. Well, one of the points that he made is that air intake tower doesn't rise up automatically. It rises up manually. So stupid. So you have this big fancy case, you throw in all these graphics cards, and then how many people, you hit the power button, how many people are going to forget how many times not to hit that little button so the little tower rises up so that it can actually get the air intake that it's supposed to get. These are the kind of stupid things that you need to be thinking about when you're looking at the computer case. Again, me being an old timer, I don't want acrylic sides. I don't want things that look like stormtrooper helmets. I don't want little towers that rise up and rise down. If you ever look at the computers that I build, and I probably will be building one shortly for this track, is I like the good steel cases with a lot of a lot of grates on them, throw in a fan or two, and then that's all I have to worry about with the case cooling. I would rather my components stay cool and work how they're supposed to versus, having something that looks like it should be on the set of Star Wars. So now we get to talking about CPU heat sinks. And there are just a zillion, gazillion, bazillion different versions of CPU heat sinks. If you're going to be using some kind of, again, aluminum heat sink with a fan, the question of which heat sink do you use? It's a lot of, I think I need a big heat sink for this one. No, probably a small heat sink will work for this one. Right? There's a lot. It's a big old guessing game as far as heat sinks go. Essentially, if you think your computer is going to be running hot, get a bigger heat sink. If you think it's going to be running rather cool, keep the heat sink that you have. Now, it is important if you go out there, you buy an Intel CPU. I think with some of the AMD CPUs, normally you'll get what's called a stock heat sink. And oh, the gamers. I would never use a stock heat sink. Again, to be clear, with heat sinks, it depends on what you're using your computer for. If you're not going to be overclocking, if you're basically using your computer in order to do YouTube and that kind of thing, whatever the stock heat sink they give you is probably fine. It's honestly probably fine. You're better off plugging that heat sink in, seeing how it works, seeing if you have any issues. If you don't have any issues, then don't bother buying another heat sink. If you do have issues, then you go out and you buy a bigger heat sink. Now, when we go over and we take a look at something like Newegg, you can see that there are just, again, to be clear, there are a zillion different types of heat sinks out there. You can have heat sinks with multiple fans. You can have heat sinks of multiple sizes. One of the big issues that you're going to run into is what size heat sink will fit into the case. So if you look at this Nordica heat sink right here, this is a big old beast. That is an absolutely big old beast of a heat sink. And so one of the problems that you can run into is that if the heat sink is too big, then it can't fit into the case. So that's not going to work out for you. So you go through and you see they got flatter heat sinks, they have larger heat sinks. So you kind of go through and you figure out what kind of heat sink you want. Now, one of the things that I will say is for anybody out there that are going to be creating appliances, so basically like appliance type computers, or again, computers that are going to be out in warehouses and all that, what you might think about is going for a fanless heat sink. I like fanless heat sinks a lot, again, for these appliances. So when I talk about appliances, we're talking about like digital surveillance systems. We're talking about maybe telephone systems. Essentially, these are relatively low resource servers or computers that do whatever they do 24 hours a day, 7 days a week. Essentially, you plug them in, you turn them on, and they're really only ever going to get turned off again, when there's a power failure or when they're going to get replaced. I like these fanless heat sinks because then you don't have to worry so much about fans failing. You don't have to worry about the vacuum cleaner effect, things getting so dirty. Essentially, with these fanless heat sinks, they're very, very large heat sinks, so you have to make sure that you get a case that's big enough to actually be able to shove one of these things in, and then the fan, the case cooling fans are what try to keep the CPU cool. Again, if you're dealing with i3 processors, you're dealing with i5 processors, this should be good enough for you. You're trying to deal with an i9 processor, you're trying to overclock it. Obviously, this probably won't work out. But there's all kinds of different heat sinks to be looking at. Which heat sink you choose at this point. You got to be thinking about how hard are you going to be pushing the CPU. Again, to be clear, if you're not doing overclocking, just a stock CPU or just one of these little crappy CPU fans and heat sinks should be fine. On the other hand, if you're going to be doing overclocking, you might want to go for one of these bigger jobs. Now, what about liquid cooling, you ask? Eli, talk to us about liquid cooling. So this is something that's become more and more prominent over the past 5 or 6 years. Liquid cooling's been around for a long time, basically with the video gamers and really with these high-powered video game systems, PCs. Liquid cooling has become a more prominent issue. I'm again, I'm me. I'm me. You all know who I am. I'm not a huge proponent of liquid cooling, simply because, again, I'm not a huge proponent of overclocking. I don't push my systems to the absolute max. And essentially, with liquid cooling, you're adding additional components where they may fail. And again, there's a cost to it. I've never found liquid cooling to be something that I've been particularly interested in. Again, this is something you have to be thinking about with what you're going to be using your computer for, and then the cooling situation. Remember, if you're going to be doing video games, the cooler you can keep the components, the higher resolution you can get. So if you're trying to do, 4K 60 frame per second, you need to keep your components as cool as possible. Essentially, that computer is going to run as hard as you allow it to run. And so, by doing liquid cooling in order to keep the components just a little bit cooler, that will allow you to get that performance. And a lot of people, again, when they're doing video games, it's not like video encoding even, where I may encode a video, but it encodes for 20 minutes or 30 minutes or maybe an hour, right? A lot of these video gamers, they're pushing their systems incredibly hard for an hour, 2 hours, 5 hours. And so when you're pushing that hard, again, you have to keep your components very cool. Now there's all kinds of different liquid cooling systems out there. Everything's from basic, pull it out of the box and it's rather easy to install, all the way down to tanks and reservoirs and doing all kinds of custom stuff. When you look at this is one of those where you do need to do your research. You need to take a look. Again, you're going to be overclocking the systems. You need to figure out how cool that you're going to need to try to keep your components. You have to figure out what is actually going to fit into your case. And then a big thing, again, with liquid cooling, kind of goes back to the whole RGB light situation, where a lot of people like liquid cooling because it looks cool. Whether or not you actually need the liquid cooling, they like, different color liquids to be going through their system. And so these are some of the things that you need to be thinking about if you're going to go down that whole liquid cooling route. When you take a look, the basic idea of liquid cooling system is essentially, if we go over, you can see that basically you've got a radiator. So this is the radiator. So the liquid goes from the radiator to the heat sink that's over the CPU or GPU, depending on the situation. And then there's a little pump that circulates the liquid from the radiator to that CPU. Then with these, basically you have big old fans. So this is just like a radiator in your car. So the heat is taken from the liquid, gathers the heat from the CPU, that goes in the radiator, fans blow over the radiator, cools everything down, then the liquid goes back. Using this, you can keep your components a lot cooler than simply using air cooling, but again, it adds in different components to your system, adds in cost, adds in complexity. So this is just one of those things. Whether or not you do it is going to be on your particular situation. Really, in the modern world, it's mainly gamers. Honestly, it's mainly gamers. If you're not gaming, you probably don't need liquid cooling. And that's what I've got for you as far as cooling is concerned. We'll probably have some other classes on things like liquid cooling. Again, liquid cooling is a class unto itself, so we'll probably do a class on liquid cooling. But basically, I mean, most of this stuff is just kind of common sense things. Really, the big problem with cooling issues is just keeping noobs from being noobs. When you're new, when you're 20, you want to go out there, you always want to buy the most powerful system so that those secretaries, man, they can be blazing fast while they use Excel. And the thing is, you go out there, you buy these expensive computers, these higher end computers, their size, the question of where do you put them, then the question of cooling, all of that kind of thing. And that's where a little box like this may make a lot of sense. I think this thing from Azultech costs you like $200. You got a nice little $200 thing. You can actually screw this right onto the back of a monitor. You don't have a lot of problems here. It stays cool. It stays relatively cool just by doing what it does, and you don't run into any major issues. Again, the same thing is like with graphics cards. You sit there, and a lot of times I see this, like why I used to use these types of graphics cards is on motherboards. For whatever reason, either the onboard graphics would fail or the video card port back then it was either AGP or PCI Express card would fail. And again, they're not video gamers. They're not doing anything fancy. They just need to be able to do word processing. And so you go out for like $30, you can buy a graphics card like this. I think honestly, like at Micro Center, I bought this thing for $37. You just grab a crappy little $37 card like this, a PCI card or whatever. You shove it into the computer, and it just does what it needs to do. You don't have to worry about cooling problems. You don't have to worry about fans failing. It just trucks along 24/7 and gets things done. So these are some of the things to be thinking about. Again, the environmental situation. So much is true. Again, with cooling, especially in the real business world, a lot of it is in the overall environment the computer is in. You can have all the fans in the world, but if it's 100 degrees in the room, you're gonna have issues, right? And that's what you have to think about. It's like the ambient temperature, especially with any of these systems. With any of these systems, they don't actually have their own little internal HVAC. All it is fans. Even the liquid cooling. Remember, liquid cooling still can only cool down to ambient air. So if the ambient air is 100 degrees, your system is gonna have some troubles. It's gonna have some problems because the coolest it can ever get is whatever the air around it is. So you run into issues that way. So this is just a little class about thinking about cooling. Cooling is they talk about in the networking world, troubleshooting. The networking environment is that it's always a layer one issue. Like 90% of the time, it's a layer one issue. What that essentially means is when you can't connect to the internet or you can't connect to the network resources. Most of the time, it's because somebody unplugged the cable out of the back of your computer. Layer one, and cooling, I would argue many times, is kind of like the layer one problem of the computer repair world. So many times computer shuts down randomly for some reason, probably cooling. Computer freezes up randomly for some reason, probably cooling. Computer starts doing really weird stuff, like the mouse like jumps all over the screen, it's probably cooling. If you have really weird issues with the computer, crack open the side of the case and look at the bottom of it for like any like fans that are just sitting there because they've broken themselves off. That's probably the issue that you're going to be dealing with. So that's all I've got to say about cooling today. As always, I enjoyed doing this class and look forward to seeing you at the next one.